Hi guys, this is Monit. I will be solving the MYP assessment in this series, question by question. So, if you wish to have all the resources with criteria wise questions from all the topics of the MYP physics, you can check the link is there in the description. You will get all the details of the syllabus with the explanation and with the worksheets, and a bonus for you to solve a past year papers with all the details with the marking scheme. Wish you all the very best for your e-assessment. Enjoy the video. Okay, guys, so this is question number one. Just pause the video and I showed you the multipliers, formula sheet, periodic table, calculators, and all. So just pause the video and try to solve with me. Okay, so identify the location of each of the substance in this coal-fired power station. So we already know that it's quite simple here. This is the coal. So you just drag and drop. This is the steam, and this is the water. So you can see that these are the marks here. So it's a one mark, part A. Now the next one. Absorbing heat can affect the kinetic energy of the water molecules. State how water molecules are affected by this increase in kinetic energy. Again, it is of one mark. So you can say that as the kinetic energy is increased, the average kinetic energy of water molecule increases. So you can just copy and paste from the question, increases. That's it. Okay. No need to mention more than this because you have to save your time and you can utilize this time in answering your criteria equation. So this is more than enough. Now C part, just pause the video and read the question. Okay, so look here. The question says water boils into steam. So whenever there's a change in phase, okay, we know that there is no change in temperature. All the energy is being utilized in order to break the intermolecular bonds, right? So the question is asking outline what happens to this heat energy referring to the movement and arrangement of the particles. So with respect to the movement, we can say that the heat energy absorbed, you can say the heat energy Okay, so that is more than enough for this question. So you have mentioned about the movement, that is, there's no net increase in the average kinetic energy, and you have mentioned about the average speed of the particles and the intermolecular bonds as well. Okay, now 1D, just pause the video and solve. Okay, so calculate the energy released in 1 hour. So we know that this much amount of energy it contains in 1 kilogram, and we have this much amount of coal that is burning in 1 hour. So if you want to find out with the two significant figures, so use the calculator. We just have to multiply 2.5 into 10 raised to power. You can say this is 10 raised to power 7 times. What's the value here? 4.5, 4.5. times 10 raised to power 5, I think, right? Yeah. So you just have to, you can just copy this. If you want to copy this, you just have to press copy and then just paste it here. So that will be give you the answer here. So this much amount. So you have to write down in the correct number of significant figure. Therefore, you can say the energy is equals to 1.1 times 10 raised to power 30. And then you can say it is in joules. Okay. So this is how you answer the part 1D. Simple. No need to mention anything else. It's more than enough. Now 1E. Pause the video and try to solve. Okay, so they have given you the efficiency there. So if you go to this formula sheet, if you wish to, there's a formula for efficiency. It is useful energy output over total energy in times 100. The same you can apply for the power as well. So like for example, if I want to write down the, I will say that efficiency, or you can denote the word N. So that efficiency is equals to useful power output, okay, divided by useful power, or you can say total power input times 100, right? So you can just say like this, and then I can use the efficiency as 0.28 equals to, or you can do it in the calculator and then you can just copy it here. So you can clear all. So so we have to find out the total useful power output. So that will be 26 is the input, 26700. Let us keep it in megawatts only, times 0.28. So that will give you this in mega joules. So you can say, you can just write it down that the total useful power output is equals to this much in megawatt. Okay, so that will be your final answer. Now look at the last part. Okay, so this is nothing but the greenhouse one. Select the arrow on the diagram which would be most affected by burning coal. So you can see like these are the options you can check. So we can say that the heat energy absorbed and re-emitted by the greenhouse gases will be the one which will be most affected by the burning of coal because it produces greenhouse gases. Okay, so that's the answer for the 1F. So this is how we solve this question. And the last one from question number one, just pause the video and solve. Okay. So if you have read it question carefully, if more greenhouse gases are trapped in the Earth's atmosphere, okay, so why trapping heat energy in the Earth's atmosphere would cause more extreme weather events and changes to your Earth's climate. So basically, they are asking you about uh, the phenomena of the greenhouse effect with respect to the change in the Earth's climate. So you can say that so trapping heat energy in Earth atmosphere. So trapping heat energy in Earth atmosphere will increase the average temperature of the Earth. Okay, we know this, which will increase the sea level by melting more ice. This will also increase the rate of evaporation of water because if the average temperature increases, the rate of evaporation will increase, which ultimately affect the weather, resulting in more frequent flooding in the coastline areas as well as the drought conditions in some of the geographical locations. So this is how you can answer the question number one. Okay.